Good day. I'm Relady Angie Oarga from Bachelor of Science in Business Administration, major in Marketing 1B. Today, I will discuss the fundamentals of graph theory. In this video, you are going to learn about fundamentals of graph theory. Graph theory is an applied branch mathematics which has many applications in the field of engineering and computer science. Today, we will start with fundamental concept of graph theory. In this video, you are going to learn about graph, self-loop, and parallel edges of the graph, a classification of graph based on self-loop and parallel edges of the graph, which are simple graph and multigraph. On more classification, infinite and infinite graph. Let us start with the definition of graph. A graph is represented by G equal to ordered pair of BE. The set B is the vertices. The set B is set of vertices. The set B is the set of vertices, and another set is set of edges. Elements of set B are B1, B2, B3, and so on. Elements of the set of E are E1, E2, E3, and so on. And each edge of EK is identified with an unordered pair of VI and VJ. That is, for each edge EK, we can write by unordered pair BI and BJ. They are the vertices BI and BJ are all vertices represented by points, and each edge are represented in line segment joining vertices, and we can draw the line segment by straight line or curved line, or in the form of loop. A graph has two types of representation. One is a form of diagram, which are called graphical representation. Now, this is a graph with the vertices and 7 edges. Vertices are B1, B2, B3, B4, and B5. And the edges are E1, E2, E3, E4, E5, and E6 and E7. When we write this graph mathematically, we will write it as G equal to ordered pair of BE. The set of vertices of elements B1, B2, B3, B4, and B5. Vertices of graph set of edges have elements E1, E2, E3, E4, E5, E6, and E7. And in the condition that each edge identify with a certain ordered pair of vertices, we can see this edge EI start with the vertex B2 and end with vertex B2. It means edge EI is identified by the pair B2 and B2. When we talk about this second edges, E2, it lies between vertices B2 and B4. That is, we write it E2 in between the vertices of B2 and B4. Now, B1 lies in each edge E3, lies between vertices B1, B2. So, when we observe edge E4 and E5, both edges are identified by vertices B1 and B3. That is, E4 in between vertices B1 and B3, E5 in between vertices B1 and B3. Likewise, we find edge E6 identified by pair of vertices B3 and B4, and the edge E7 identified by pair of vertices. Next, we will define self-loop. Self-loop in a graph, an edge having the same vertex as both its end of vertices is called self-loop. If we observe this graph, we find that this edge EI, identified by the pair of vertices, this edge EI is a start the vertex to B2 and end at vertex B2. Each edge both our vertices are same, so this edge EI is a self-loop. Next, the definition is parallel edges. Parallel edges is a graph of edges having same pair of end vertices are called parallel edges. If we observe this graph, we find that edge E4 and edge E5 identified by the pair of vertices B1 and B3, so edge E4 lies between the vertices B1 and B3. Edge E5 lies between the vertices B1 and B3. Edge E4 and E5 both identified by the pair of vertices B1 and B3. Therefore, E4 and E5 are parallel edges. Next, we will discuss the classification of graph based on the property self-loop and parallel edges. A graph that has either self-loop nor parallel edges is called a simple graph. This is an example of graph. We may observe in this graph have vertices B1, B2, B3, B4, and B5, and 6 edges E1, E2, E3, E4, E5, and E6. There is no edge which are same edge and vertices, and there is no two edges which identified by the same pair of vertices that is in this graph. There is no self-loop and nor pair of parallel edges, so this is the example of simple graph. Next graph is multigraph. A graph with parallel edges which are called multiple edges is called a multigraph. This is an example of multigraph. We can see we only have 3 vertices B1, B2, and B3, and the different pair of parallel edges. So this is example of multigraph. Now, we'll see how we can draw a simple graph and a multigraph. Suppose we have 5 vertices, name this B1, B2, B3, B4, and B5. So we may draw 5 points for B1, B2, B3, B4, and B5. Now, we have edges E1, E2, E3, E4, E5, and E6. Now when we have this graph, it is a simple graph which have 5 vertices and 6 edges E1, E2, E3, E4, and E6. As this graph there is no self-loop, no pair of parallel edges. Now suppose this graph contains some more edges which has parallel edges. Let's say this E7, E8, E9, and E10. Now this graph has edges from E1 to E10. So this is a multigraph with 5 vertices and 10 edges. Next definition is for finite and infinite graph. A graph with finite number of vertices as well as finite number of edges is called a finite graph. In other words, it is infinite graph. When we observe this post graph, this graph have 5 vertices, that is, number of vertices are 5 and 7 edges. Number of vertices and number of edges are finite, so this is an example of finite graph. Now, in the second graph, it is one partial of infinite graph. We may see this graph continues for a long. We can find exact number of vertices and edges, so the number of vertices as well as number of edges are not finite. That's why it is an example of infinite graph. In this video, we discussed the fundamentals of craft theory. I'm Relady Angada sa Oarga, taking the Bachelor of Science in Business Administration, major in Marketing 1B. To our teacher in Mathematics in the Modern World, Mr. Mark Christian P. Ranes, thank you